Compression continues to be normal.
Our EDT pressure looks good.
Doubling up. Roger roll, Atlantis.
Water towers fly! Yes!
Tango Delta nominal.
Flight downside SC off. Bring in SC off.
Yikes. You bet. Concur. We don't need any more of these.
All right, folks, you know the drill. Super light staff here running NSF Live, but let me know if you can see us. We have our special guest, Peter Beck, today. Me and Thomas here as well. Let me know if you can hear me, too. Give me some 5x5s in chat, and if everything's working correctly. Little bar's jumping, so I assume that it's working correctly. I got 5x5s in chat. Thank you for the help there. So let's go ahead and get started with another exciting episode of NSF Live. He was on the thumbnail, so I already knew who the special guest was going to be. But please give a big, warm NSF welcome to Mr. Peter Beck of Rocket Lab. Peter, how are you doing today?
Oh, I'm doing really well, thanks, guys.
Outstanding. This is not your first time on the show here, right? You've been on our show before, I believe.
Yeah. I think we had a chat a year ago or so. I think.
We have. We were looking at you running battering rams into pieces of stainless steel or something like that last time.
Yeah.
All right, and then also on the show today we will have Mr. Thomas Burghardt, news director for NSF. Thomas, how you doing?
Oh, I'm doing well. Glad to talk to Peter again. We've got a lot of exciting new Rocket Lab news to talk about, so it should be good.
All right. Well, we are going to get the show started right away. We've got 90 minutes here, folks. Quick housekeeping. You know, this is a live show. Unless you're watching a video after the fact, but don't get confused by that. If you've got questions for us, tag us in chat. Just put at NASASpaceflight, or just be like, hey, I have a question. If you get us tagged at NASASpaceflight, it goes into some cool software we have here. We will choose questions over the course of the show to ask Peter here. We will try to make the questions topical and, of course, appropriate. So if we don't ask your question, well, maybe we just didn't get to it. But please ask questions that are relevant to what we're talking about at the time. Don't completely try to change the topic. And also, if you're doing things like super chats or gifted memberships or anything like that, we totally appreciate those. But on special event shows where we get a special guest, we try to give all the time to the special guest. So, along those lines, I'll stop talking here, and let's go ahead and get going with the show. Thomas, Peter, where are we going to start today?
Well, I think we should start with Rocket Lab's most recent launch. They launched It Argo's Up From Here, a successful Electron mission from New Zealand. And Rocket Lab just starting to hit a bit of a stride here. And Peter, I'm just asking, how is your normal Electron operations going so far? Are you implementing any lessons learned, or are there just kind of evolutions as the launch system matures that has allowed you to increase the launch cadence a bit here recently?
Yeah, look, the number one thing that really drives our launch cadence is our customer readiness. We've changed the way we do things a little bit with respect to scheduling, and we built another clean room so we can process multiple customers at one time, and that's really probably been one of the biggest enablers, for this monthly cadence this year is actually making sure that our customers are there on time, and we get them integrated on time, and we can push a launch vehicle out to the pad on time.
And speaking of launch pads, I think one of the biggest topics that we're definitely going to want to dive into today, now that you've got 2 operational pads down in New Zealand, is the 3rd launch pad that's now coming up in here in the United States at Wallops, Virginia. And it sounds like that first launch is coming up as early as December. So what kind of forward work is Rocket Lab?
Did you just say Peter Lab?
I combined Peter and Rocket Lab. My fault. What's Rocket Lab working on to get ready for that December launch date for this Hawkeye mission you got coming up?
Yeah, look, I mean, that pad's been ready for basically 2 years. I think we dressed on that pad about 2 years ago. So it's all been waiting on the NASA AFTS software certification, which we run that AFTS system, have done for I guess nearly 2 years now, out of our New Zealand pad, but it requires NASA to sign off their own piece of software. So that's been the only thing that's really been governing the launch timing there. And the team at NASA has been working super hard, and we've been monitoring progress there obviously very, very closely, and throwing every bit of resource that we could at it. And it looks like it's all going to come together. It's going to be tight, but it's all going to come together, and we're going to finally get that launch out of Lc2, and then you'll probably see a few more pretty closely up the back of that, which will be good.
Yeah, I think we actually have an Investor Day slide, and I'm going to be referencing the Investor Day materials a lot because that's a lot of the recent news that we definitely want to talk about. Another
Sure.
mission coming up in January for a confidential commercial customer, so I won't inquire on who that is. But another mission coming right off the back. So basically,
Yep.
once that first mission happens, you'll expect a pretty rapid cadence quickly.
Yeah, we will. Yeah. I mean, there's a lot of pent up demand to fly out of that site. So we'll try and let some pressure out of the balloon on that one and get a few away early, and then it'll be pretty cool. We can just chop between southern and northern hemisphere launch and range requirements as they rise and fall.
Yeah.
Well, yeah. So, go ahead, Doc.
But I was going to say really quickly, for people who may not know exactly what we're talking about Lc2, and the cool thing about Lc2 is that it is not on the super secret lair island that you've seen down at New Zealand, the one of the most, if not the most picturesque launch site in the world, honestly. This actually has a very familiar water tower next to it, because this is on Wallops Island over in Virginia, here in the I say here in the United States, I'm in the United States. In the United States. So when we say Rocket Lab's Lc2, we're talking about these first launches where they will be launching not from New Zealand, but here from the States. I think we had a little bit of a map sort of presentation thing. We don't do presentations, but I'm not kidding. Clearly, here's my house. I live in Charlotte, and I say here in the United States because we can just go up to Virginia, Chincoteague Island, and this is where the Wallops Island launch facility is. The Antares rockets fly out of there. You've seen a couple of our videos from there, but Rocket Lab actually has built that new infrastructure. I guess has built some infrastructure and is continuing to build infrastructure there, right, Peter?
Yeah, so actually, the Lc2 is people just think it's a pad, but we built a whole ICF building as well in the Innovation Park that can process 2 Electrons at once with multiple clean rooms and control room. And then, of course, you've got the whole Neutron setup, which is I'm not sure how recent this Google Maps is.
Not very.
You actually
Not very.
Well, you're not going to see all the concrete and stuff that's laid down there for Neutron then, but. Yeah, we've got quite a bit going on in that region for sure.
All right. So the Lc2 is the Electron pad, and you're working on another pad, right?
Correct.
All right.
Yeah.
Go ahead, Thomas.
Yeah, I think we've got, when we get to Neutron here in a bit, we've definitely got some Rocket Lab pictures of the production complex and things like that, and we'll definitely come back to this map to talk all things Neutron.
Excellent.
You mentioned the Lc2 launch cadence that's going to come up pretty quickly. How is that going to compare to your Mahia launches? Do you expect that to be some sort of 50-50 split, or how are they going to compare to one another? You mentioned a lot of demand for the Wallops pad.
Yeah, so it'll move around a little bit. It would be great if it was kind of as predictable as 50-50, but it kind of rises and falls depending on what missions and what customer. The Lc2 pad was primarily built for rapid on-demand launch for our defence customers. So that was its primary purpose, and the whole pad is geared around how do you get a rocket from the ICF and out to the pad and launched within sort of 24 hours.
Okay.
So that, although ironically the first customers that are flying out of there are in fact commercial. But it'll move around between Mahia and Lc2. Quite frankly, the launch I want to do though is Northern Hemisphere and Southern Hemisphere simultaneously. I reckon that would be one to do.
It balances out, so you don't affect the orbit of the Earth by launching.
Yeah, we don't slow. Yeah.
Now, is that something that would be a demonstration? I was about to ask, would you do any sort of 24-hour integration rollout launch demonstration? Would there be a reason to demonstrate 2 simultaneously launches from 2 different hemispheres? Could you think of one to justify doing it?
But I'm sure if we think hard enough, we'll figure out a reason why that has to be done.
It's like just because you can.
Demonstrate capability.
There you go.
That's actually a great question that I saw in chat over here. Do you still control everything from your primary launch pad? Like your mission control is still in one place? Or are you going to have 2 separate geographically diverse mission controls? Or how's that going to work with the Wallops pads?
Yeah, so we have a mission control here in New Zealand. We have a mission control in our headquarters in Long Beach. We have range control down in the Mahia launch site, and we have range control at Lc2 in the ICF and in a Rocket Lab controlled building. So when we launch out of Lc2, we'll probably use mission control at headquarters in Long Beach, and we'll use range control at Lc2. But I mean, actually, there's no reason why we couldn't use mission control in New Zealand. Obviously, you need to use range control.
Right.
But when we did like the Capstone mission, for example, we ran one shift here in New Zealand and then another shift in the American Mission Control Center in headquarters. So they're all kind of pretty seamlessly linked.
Yeah. All right. That actually leads right into another great question about the new pads. Like, what's the biggest difference between launching at the Virginia locations and Washington, New Zealand locations? Is there a difference in transporting rockets, or is there like extra paperwork because one is the NASA or Mars or whatever? What's the big difference there?
Yeah, look, I mean they're the same pads, and we built 3 of these launch erectors and whatnot. So it's all the same. The big difference is, I think you hit the nail on the head, is when we launch out of New Zealand, it's a private orbital launch pad. We launch under an FAA launch license, and that's it. When we launch out of a federal facility, obviously there's a NASA contingent that goes along with that. So we have essentially an FAA launch license and a NASA launch license. Hence the reasons why we can't just launch out of Lc2 without the NASA sign off on the AFTS. So there's kind of like 2 governing bodies that you have to work with.
Gotcha.
On that AFTS, I think in a previous conversation you actually mentioned that part of getting it NASA certified and everything like that was also being able to sell that as a package to other launch providers as a just self-enclosed AFTS system. Is that still a plan for Rocket Lab?
Yeah, look, I mean, I think everybody knows our first flight was terminated from a ground-based AFTS system that that lost track. So we're very passionate about flight termination systems, having experienced that. So after that, we vowed and declared never again. And we've had a long partnership with both DARPA and NASA, developing this autonomous flight termination system, making sure that it's available for everybody. And part of the reason why it's taken NASA so long has been making sure that the system it just doesn't work on Electron. It can work on air launch vehicles. It can work on SLS if it needed to.
Hey.
So we've certainly taken one for the team on AFTS development in the industry. I think all said and done, it's going to be great for the industry, but it certainly it's been pretty painful for us. We've not been able to launch out of Lc2 until that work has been completed. But I think at the end of it, it'll be a great flight termination system for everybody to use.
Gotcha. You said SLS there. How long do the batteries last in your flight
Oh,
termination
no.
system? Sorry. Okay.
No, brilliant.
Okay, Thomas, I'm going to keep pulling some more questions out of chat, but you continue on while I do that.
Yeah, just jump in whenever you've got a relevant one.
Will do.
Other Electron questions that I've got asked involve around reusability, and we can certainly try to tie that in with Wallops here. But for starters, the first catch attempt that happened down in New Zealand, the catch and release, if you will. How's Rocket looking at for another catch attempt here in the hopefully near future?
Yeah, so you shouldn't have to wait long for that. The team's hard at work at the moment. The kind of the catch element is we have that we're fairly well defined. We're pretty happy with that. What the team's been working on at the moment is an ability to basically catch the rocket and then fly it all the way back to either the launch site or an offloading dock. And you can't have parachute flapping in the wind as you're flying along at 100 knots. So there's additional systems that we've been working on that constrain the parachute after capture, so that you can fly with a rocket under the helicopter with a streamed parachute at a good velocity to be able to fly either back to the launch pad or to another landing zone. So that's where the majority of the work has occurred. We're super happy with re-entry now, super happy with guidance, although we kind of released the last one, we've done lots of testing since then, and we're super happy with the catch. But we'll go and you shouldn't have to wait long, and we'll announce something here shortly, and we'll go and do it again. But I mean, there's silver rockets running down the production line now, as a standard product, and we're pretty much just making this operational at this point. But what I will say is, man, we've learned so much through this whole process that Neutron's design is the way it is because of these learnings. And I think if we hadn't done the Electron reusability program, we would have made a whole bunch of mistakes with Neutron that that you wouldn't have found out until you started flying stuff.
Yeah.
Right. Was totally gonna. I was almost assuming leading into that question, because I think all providers that have gone into reusable rockets have definitely implemented lessons learned and done block upgrades, things like that. And I can only assume the same applies to Neutron. I think we even saw, you mentioned silver rockets rolling down the production line. I think we've even seen Neutron or Electron, that could have been caught or reused, but we're just launching as expendable because that's just what the production line produces these days.
Yeah, so and whether a vehicle is reusable or not is kind of dependent on a few things. One is the trajectory, obviously, and the performance margins in the vehicle. We lose about 10 to 15% of the performance of the vehicle with reusability. So depending on how much margin, and then the final one is the customer. So the silver rocket you saw launch was obviously for the NRO, really important payloads, really important customer. That wasn't really one that we wanted to experiment on in any way, shape, or form. So we can fly them in expendable mode or reusable mode. But at the moment, I'm not sure. Can't remember if it's every fourth rocket or don't quote me on that. But periodically every one is just a reusable vehicle, and we either kind of put it to the one side for a reusable mission, or obviously reuse it. That's the best case. Or if we have to fly it, just fly it. Like the cost of a reusable vehicle versus a standard vehicle is almost negligible.
Yeah.
Sure. Okay.
Does it cost the same, like in terms of what you would charge a customer who's flying something? Like, do they make the decision reusable or not, or do you make the decision? Do you leave it up to them? Is there a price difference?
Well, I guess at the start of the stage of the program, it's definitely a lot of customer discussions. Because we're not catching these frequently and reusing them and putting them back. I mean, where the program is at the moment, we would never enforce a reused vehicle on a customer. The ironic thing is that the reusable vehicles will probably have more attention to detail on them, especially the early ones, than probably even a flight vehicle, because we'll be looking at absolutely everything with a fine-tooth comb in excruciating detail. So they probably have more mission assurance on a reused vehicle than perhaps even on an expendable. But until we kind of really get in that groove, and as you've seen with SpaceX, it takes a while to get into that groove and really understand all the service lives of every component and making sure that all the environments are as you expected.
All right.
So as that system moves towards operational maturity, how many of your missions, both in New Zealand and then maybe once you can move those operations up to Wallops as well, what portion of your Electron manifest would you expect to be able to be supported with reusable vehicles?
For Electron, I think it's probably 50-50 because you still need some performance on the vehicle, on some missions, and also in downrange in winter at night in a thunderstorm.
Right.
We're not going to fly a helicopter and try and catch a rocket. We're just not. So those missions will be unlikely to be reusable. And if we have one of the things that people come to fly on us on is scheduler surety, and that also means like T0.
Yep.
So when we commit to a T0, if you look at most of our launches, they're instantaneous T0s for our customers. So we're not going to. That's the priority. So we're not going to mess around with that.
Right. That makes sense. Like something that a lot of people don't understand is if you're trying to recover or reuse or land or whatever your rocket, right, you have two areas where weather is important. It's not just the launch pad, it's also where you're going to try to recover it, and that can actually make it maybe a beautiful day at the launch pad, while downrange where the helicopter's trying to fly, it's not so great, and that can affect your ability to launch, right?
Yep, 100%.
All right.
And so you've brought back, though, a couple of boosters that either were caught and released or didn't even have a catch attempt, and you've gotten data from those, surely. What has that data looked like, and have you been able to test fire or perhaps even reuse components from those vehicles, even though they weren't brought back dry?
Oh, totally. Yeah, I mean, we've re-entered, and we've re-entered 5 vehicles, and I think 3 of them we've put back in the factory. And of those vehicles, we've stripped components on, like whole press systems. We've reflown. We've pulled engines off and serviced them, and hot-fired engines. No, that bit I'm not worried about. Like we're looking super good there. And the re-entry environment, we've got it smoother and smoother every time, and it's looking super good. So very, very happy with that.
Would you expect there to be any operational reusability from vehicles that can't be caught and can only be recovered after a splashdown or something, or are you going to limit that to vehicles that can be caught, brought back dry?
Yeah, I mean, there's just so many unknown things when you go and take it for a dunk. Look, we've proven that you can pull stuff out, but the vehicle was never designed to be dunked in salt water. We've pulled components off, like whole press systems and vent relief valves, press valves, and all that sort of stuff, and pulled them off. And cleaned them and inspected them and reused them. So certainly we could do that. But the idea, the strong desire here is to just keep it dry and keep it away from the sea. Look, absolutely, if we dunked a few, then there's a heap of components that are good, and we've also proven that we can take an engine and with a relatively light amount of resurfacing, even though it's been dunked, hot fire it again. I mean, the engines are made out of Inconel anyway, so the corrosion's not really too much of an issue there. It's a totally doable thing.
All right. What else? The last Electron reusability question I've got already prepared, and then Daz, please jump in if you got more chat questions on that topic. But you mentioned lessons learned being applied to Neutron. Anything specific that has been really eye-opening regarding engines, thermal protection systems, guidance for re-entry and recovery that's going to be applied towards the medium lift vehicle?
Yeah, so re-entry is actually a thermal problem. Everything kind of bears down to the fact that it's a thermal problem, and the best way to deal with a thermal problem is to not have a thermal problem. So if you look at Neutron, it's got a really, really wide base. So that means that it's like literally like a shuttlecock. So super wide base, super low mass. You put the ballistic coefficient where you need it. Then and because if you have a very low mass, you have very low inertias and energies. Then the actual heating of the vehicle is relatively light. And Electron is the same. Like Electron as a vehicle is got a really, really high mass fraction, especially on stage 1. Being so light, it decelerates really quickly, and we don't actually generate too much thermal energy on the base. And also, if you can control the re-entry corridor really, really accurately, then only the base really sees the temperature, and you can control that that heat flux around the vehicle. And if you look at Neutron, it's got a continually kind of descending diameter as it starts at the base and up to the top, and that's basically so that you have a continually changing pressure gradient over the length of the vehicle, so it just ensures you have no shock waves attaching to the outer skins of the vehicle. So what that means basically is that you don't need to get carried away with thermal protection systems up the side of the vehicle. And if you look at Electron, it's a 100% carbon composite vehicle. There's robust TPS on the base where it needs to be anyway for ascent, because you have a whole lot of plume-plume interactions and recirculation flow at the base anyway. And then, but up the side of Electron, you'll see that like we have this aerogel, high emissivity coating, which is really belts and braces. It's only sort of 0.1 of a millimeter thick, so it's super thin. And that just helps some of the radiant heat flux that you see on re-entry. So all of these things really feed into Neutron's design and development, and the material selection. Like Electron is an incredibly light vehicle, and Neutron will be an incredibly light vehicle. And those things really, really help you when big ballistic coefficient, super light vehicle. It's the perfect kind of re-entry
Gotcha.
candidate.
Yeah, basically it's got a large amount of drag and a low amount of mass, so it slows down really quickly. It's like trying to throw a feather versus a ball bearing or a golf ball or something like that, right? If you got a lot of mass and not a lot of drag, it's going to not want to slow down. If you got a lot of drag and not a lot of mass, I mean, how far can you throw a feather, really, right? So...
Yeah, I think of it like a shuttlecock.
Yeah.
You know, you give that thing a good old whack. It's frustratingly so, and you know, it slows down pretty quick.
Yeah. All right. We've got a couple questions here that sort of are relevant to Electron. So let me see how we can get some of these. In this, Peter, just waggle your eyebrows if you can't answer this one. But I do want to ask because I'm interested. Just be like,
Sure.
but
fine.
when you launch, like what would be for us a classified payload, right? Like a national security payload or something like that. Do you actually know what it is, or is it just like a black box that says "Do not open" and you just put it on the rocket and you ship it? Like,
Yeah, look, there's a really robust payload permitting process in which, when it's launched out of New Zealand, especially, there's like there's kind of basically two balances and checks.
Right.
One obviously it goes through all the appropriate interagency reviews to get a FAA launch license in the US, and there's a secondary process if it launches out in New Zealand from the New Zealand government that it goes through again. So you know, there's lots of checks and balances, you know, to ensure that the right people know what the payload is, and its purpose. Yeah.
Okay. Good. I had never thought about that before. Like I just assumed you know what's on top of the rocket or whatever. So let's see here. Could you? This one, it's not specified, and I think I know the answer. I don't think that Electron would have this sort of range, so maybe this is for Neutron. But could you fly between your two launch pads? Like, could you launch at Wallops and land in New Zealand? Or is there anything that would keep you from trying that, maybe with Neutron?
Well, with Neutron, you know, the first stage downrange, you know, it's even on a pretty healthy ballistic arc, you're not going to get, you know,
halfway around the world.
But if you certainly the second stage, you could, you know, if you re-enter that somehow, not that that's designed to re-enter, but re-enter that, then I guess that would be possible. But it's kind of a little bit pointless landing a second stage you know, on another continent, I think.
Yeah. And most of the time, like the first stage is not designed to fly halfway around the world. It's does a boost back sort of thing. It lands on a platform or island or something that floats in the water above all the marine mammals. But it's not 10,000 miles away, right? It's 800 miles downrange or something like that. It's some distance downrange, not halfway around the world, which is sort of your two different launch pads. I guess I haven't looked to see if they're two halfway around the world, but it's pretty close.
Yeah, and if you look at the trajectory optimization you need to do to get to orbit efficiently, I mean, the boost is really to get you through the soup, right?
Yep.
So you're up and out of the soup and then start your pitch over, but the majority of the rotational velocity is achieved by the second stage. So you'd have to see how far you could lob something downrange, but I don't think you could get intercontinental, that's for sure.
Even if you could, it might not be efficient to try and do that. Like that's not.
Well, you wouldn't get to orbit, that's for
exactly.
sure.
Right.
Yeah.
All right. How many launches do you have coming up on the manifest from Wallops? Like, if I'm a U.S.-based launch fan over here on the East Coast, am I going to see it flying once a month next year, or what are you sort of looking at there?
Yeah, it'll start off pretty busy down there. So there's the two that we've announced, and then I'll get in trouble if I start announcing other launches without everybody's approval. But I mean, it'll get off to a busy start then the beginning of the year next year. And look, it's an asset that we love and we want to use it as much as we can. So we'll flip between the two sites as appropriate.
Gotcha. So let me rephrase the question maybe. What is the turnaround time for the pad at Wallops? Like, assuming you just had a list of customers and they just were bringing payloads in on trucks as fast as they possibly can, what would be your limiting factor? Like, how quickly could you actually launch out of that pad?
Well, the limiting factor at that pad, would be a couple of things. One is the team size. At the moment it's sort of set up for 1 a month cadence, but if we wanted to do more than that, then we need to swell the team size a little bit. As I mentioned, the ICF is capable of processing 2 electrons simultaneously, so so that gives us a lot of scope to grow there.
Gotcha.
If we need to increase that cadence.
All right.
You do mention that the first mission for Wallops is going to be this mission for Hawkeye 360, very prominent commercial small sat company, and this first flight is the first of 3 that you already have on contract with that company. Would you expect, if someone was hypothetically planning, I don't know, live broadcast coverage of launches from the United States, would we expect those missions to be taking place from Wallops, or is that a multi-launch site thing? I'm just asking for a friend,
Asking for a friend.
Yeah, well, the true answer to that is depends on trajectory because obviously we get a much more efficient sun-synchronous corridor out of Mahia than we do out of Wallops. So depending on the inclination that customer may desire, we'll kind of determine that a little bit. There is a super nice sun-synchronous corridor out of Wallops with a dog leg, way less energy intensive than out of the Cape.
Right.
Okay.
But nevertheless, it is still it's still a dog leg, and on a small launch vehicle, you very rarely do you have the performance margin to do dog legs. So it really depends on trajectories. And of course the customer's desire to which launch site they want to launch from.
Sure.
It might not surprise you that a lot of customers actually prefer to launch down in Mahia. There's always a large contingent of people that you've never met turn up, watch a launch, and there's jet boats and bungee jumping and all sorts of things ensue. So.
The customer support team that is critical there to observe the
Very
launch.
critical to the mission, for sure.
The list is huge.
Yeah.
Well, that's probably my best chance to get down there to actually see a launch. I'll have to convince the wife that we should just go to New Zealand when you're doing a launch. So.
There you go.
All right.
So those launch corridors from Wallops, so you have a dog leg that gets you to sun synchronous south, going southbound, I would assume. So you have everything from that up until some mid-inclination going northeast from Wallops, I would assume. Basically, I know they can do ISS inclination, obviously, so something around there.
Yeah, yep. I mean, there's a few cutouts for obvious reasons in some of the trajectories, but that's why we love Wallops. I think it's a somewhat of an undiscovered jewel that you can actually get a lot of trajectory out of there, and it's not too busy, which is great.
Is that I'm going to draw on the map, so I want to make sure I get this correct. Is that like a southern dog leg when you're talking about the dog leg out of Wallops? For people watching, if you don't know what a dog leg is, it's when the rocket sort of turns mid-trajectory. On the map, I guess I could say. So you don't just go like on a straight launch like this. A dog leg would go like that and then turn like that, sort of mid-trajectory. Yep. Of course, I'm just making it up, but is it a southern dog leg there?
Yeah, I believe it is. Yep.
Okay. Gotcha. So for people that don't know what we're talking about when we say a dog leg, we just mean a rocket that sort of starts on one trajectory if you're looking down on the map like this, and then it turns in a direction. You see it sometimes to avoid islands. Some of the launches that go out of India, they do dog legs to avoid different parts of the things. Going out of the Cape, the same sort of thing. Like if they want to get on a more southern trajectory, they'll go out away from the coast and then turn a little bit to get into the trajectory they want. But when we say dog leg, that's what we're talking about with the dog leg launches.
Yeah, based on that map, Dawes, I think when they do that launch, we're gonna have to keep you in North Carolina, and we'll just have you drive east. You'll go to the beach, and you'll see the dog leg. We'll have a camera view from there.
I want to do it. I want to see it go by me. Like the rockets are always going away from us. If you're at the launch site and it launches, it goes away from you, right? But if you go south or north of it and it goes past you, you get to see like almost 180 degrees across the sky. Sign me up.
Well, actually the last launch we did with Electron, just during the time of the day there. It was seen from the top of the top of the North Island to the bottom of the South Island, and as it just traipsed down the whole country. Some beautiful shots of it as it went.
Yeah, we call that the jellyfish effect around here, and that was very evident in that Electron launch. It was awesome.
Yeah.
All right, well, I know all of our launch photographers here in the States are very excited for the Electron launch and for future Neutron launches, which does bring me to the Neutron section of our show. We should talk about the new rocket coming down the pipe, which will, of course, be launching from Wallops. So how are preparations coming along for the actual Wallops facilities that will support the new rocket? Yeah,
good. So, there's... I don't know. I used a chicken turkey in the presentation, the Investor Day presentation, and basically what I was trying to say is like there's a whole heap of work that goes into something, and you see very little kind of gain for the amount of effort you put in. And then all of a sudden, it's kind of like if you're doing home renovating, right? If you start with a room, you strip all the wallpaper off, and it all just looks terrible. Yeah. And then you work and you work and you work, you make it all smooth and stop all the rock wall and whatnot. But it's not until you put the final coat of paint Neutron that you actually see the fruit of all of your labour. And it's kind of like making a rocket is similar to that. So, we've been digging holes in the ground and pouring concrete and a whole lot of really big infrastructural pieces that are super long lead, but are really, really the foundations of the whole program. So, with that, one of those is obviously the Lc2 launch site, and pouring concrete and building buildings out there, whole production facilities. It's great to see some of that come to fruition, because all of those can be like a year or more in the making, especially in today's environment. Like the thing that's blown me away is just people ask, well, how is supply chain? And because we're so vertically integrated, building rockets and satellites, supply chain we've been able to manage really, really effectively. Like there's been no launch delayed or satellite or anything like that.
Yeah.
But we, funny enough, we don't own concrete plants or steel plants. So as we're developing this infrastructure for Neutron, that's the thing that's been really tough. It's like we just want concrete and we just want steel. And the lead time for that stuff has just completely blown out.
Yeah, a lot of people don't think about that. Like, if you want to design a new rocket, at some point you're going to have to do this. Like, you're going to need some concrete and pad and all the other parts, all the infrastructure, the stage 0 we call it sometimes. I mean, the places where you prepare it and integrate it and put it together, and then you have to have launch pads, like all those things. You don't just roll a rocket out to the beach and launch it.
Well, what you're seeing there prior to that, there was a chicken farm there.
Yep.
And I wanted to call this facility KFC, Key Fabrication Centre.
Okay.
But I got overruled on that one. I think it's called something slightly more boring than that. But so there was a lot of work that had to go there, right from the beginning.
Yeah, I think one of these other shots, there's still, here we go. There's still some sort of farm in the background back there. Like, that is something all around Wallops. They have chicken farms, these long, low buildings and stuff like that. Sometimes when you're going through security over there, you smell them on the way in. So maybe thank you for taking out that one chicken farm.
Well, the beautiful thing about this site is like what you don't see in that image there. What you do on the slight right is that road on the right there is the main entry to the base. So the main gate is
right here.
You can see the main gate. Yeah. So we roll it out of the factory just down the road onto the pad is pretty awesome. Yeah.
So this is just outside of the Wallops fence line, I guess, and you just right through the main gate there, and then the launch pads are up this road over to one side. I think that's one of the water towers in the background. I don't know if that's the launch pad water tower.
It is. Yep.
It is. Okay. I feel like I'm missing a bridge or something.
I'm pretty sure it is.
Yeah.
Yep.
Excellent. So that is just right outside the main gate. I remember that chicken farm you're talking about.
I think both Dawson and I have driven past that and before there was concrete there, and we'll have to see that updated when we go to Wallops next. All right, so that's launch facilities down at Wallops, and Dawson, you got to bring the map back up because we got to talk about where the pads are going to be and stuff. So
I was planning a vacation, Thomas. Sorry.
No, that's the other pad.
Other pad. Okay, I'll get over to it. Hang on.
So we'll have a launch pad and we'll have a landing pad because, of course, Neutron will be a propulsively landed vehicle. So want to give us the lay of the land here for the new complex in addition to LC2?
Yeah, so if you zoom in to pad 0A.
Got it?
Yep.
And again, these are outdated, I think. But
yeah, it's not an Electron pad on there. And then there's that little bit of sandy bit by some buildings.
Like that area?
There you go. Yep. Yeah. So that's up. And if you go down the coast a little bit.
All right. Follow the road.
Down.
Here we go.
Right about there. Yep. Round about there, where you had your mouse. Sorry.
Right around here.
Yeah, right around there. That's down. So
that's down.
Oh, I see. Up, launch. I got you. I was picking up what you're saying.
Ascending pad, descending pad.
Okay. Gotcha. So it's like, this is sort of like outbound, and then this is like inbound, is what you're saying.
Correct.
That is the worst arrow I have ever drawn on a stream before. Sorry about that. There. Okay, that's better. I'll fill it in.
Yep.
Okay.
All right. And just expecting one launch, one landing pad for Wallops, or are you going to pull an LC1A, 1B on us?
Just the one at the moment. I think we've learned a lot about pad and pad infrastructure. So if you look at the Neutron pad, you can see there is no, well, you can't see in this image, but there's no strong back or erector.
Right.
The vehicle is designed to spend its life vertical. Breaking over a big rocket is a little bit of a pain. There's lots of infrastructure that goes with that. So, if you look at a Neutron pad, it's just super clean, and once again, lots and lots of lessons learned from operating a launch vehicle is that pad infrastructure. It's called stage 0 for a good reason, right? There's a lot of stuff that goes on there. Yeah. So the more you can remove out of that and simplify it, the better.
I will say, like, just since we're on the map, before I hop off here, I love watching launches from Wallops because there is some fantastic publicly available viewing. It's actually a pad you can get the closest to the actual rocket launches without buying a ticket or anything like that. It's the ferry landing here is actually a public viewing area. And when we're talking about Pad 0A, where they're going to have the Electron launches and the Neutron launches from, and then the landing zone down the road a little bit, I mean, if you're at the ferry dock, you have a great shot of both of those places. So if you're interested in seeing launches, you need to make sure that you follow Rocket Lab and keep up with what we're doing here. Follow them on Twitter at Rocket Lab. You know how to find NASA Spaceflight because we'll be streaming it, of course. But if you're like anywhere in, I don't know, like sort of this, get Charlotte in there, area, you should be able to get a great view from the launch pad there because you don't have to buy tickets like you do down at KSC to get close. You could just go there and you can see an amazing launch, and I can't wait until Rocket Lab is flying from there because it's such a sun's coming up in the background, and there's little birds chirping and water lapping at the dock and stuff. It's such a good place to watch launches from. I cannot say enough. Make sure you keep up with what's going on for when those launches are going to happen because if you're within striking distance, it's really a fantastic place to go and watch a launch, especially if you've never seen a launch before. All right, sales pitch for watching launches done. Sorry, Peter.
Well, I think based on Rocket Lab's cadence too, there'll be more frequent launches from Wallops than there have been recently. Other than the sounding rockets from there every once in a while too. But Antares only flies like twice a year, so between Electron and Neutron, I think that'll be more frequent than Wallops is used to, perhaps.
Yep. Book your hotels early. There's not a lot of hotels around there.
Yeah.
But I think there's also a rendering from the Investor Day presentation that actually shows what some of the launch and landing infrastructure is going to look like. And I think there's something else in that image that I need to ask Peter about, because on a previous episode of NASA Spaceflight Live, we were talking about Electron reusability, which involves marine assets and boats to aid recovery, and you were not totally a fan of those because they're frustrating.
I'm still not a fan of those.
He's still not a fan of them.
Frustrating though sometimes. Is that it maybe?
Yeah, look. So firstly, this is a rendering of in a fully developed state.
Right.
Sure. You can see all the elements there. Neutron is you can do an 8-ton to orbit return to launch site launch. It does a 13-ton to orbit downrange landing. And obviously, to do a downrange landing, you have to have a marine asset.
Right.
So that's what we have depicted in that artist rendition there is a downrange asset for those 13-ton launches if required.
Okay, so it's not like we were speculating at first when we saw this image. Like, well, is that actually like a barge or something like that? Is that just a pier? Like you should put a Ferris wheel on it or something like that? But this is actually going to float off into the distance and get a rocket landed on it, and then return over here, and it sort of docks here. This is kind of what's going on with the two. Are those train tracks?
Yeah, so if you look at the building on the far right, the rollover, so that rolls over and basically picks the vehicle from the barge, and then pulls it back onto the launch site. So
that the entire building here sort of rolls out on those tracks, and it's got cranes, infrastructure, stuff like that. So it's not
a hook on the top. Yep.
Okay, that's cool.
That makes a lot of sense. You know what? I had never even made that connection, but now I totally see it.
Yeah, so we thought it might be like a transporter or something. The transporter goes back on the rails or something like that, but it's the whole building. It's like the building is a crane, is sort of a train car sort of system, and it goes over there, gets it off the barge. Barge. Do you have a name for it yet? Like marine asset? Those dirty marine asset? What do you want to call it? Like
dirty marine asset.
Okay.
So how far along is this kind of concept? Or is this, all right, yes, we want to have a downrange recovery asset. We want to have the return to launch site profile. You'll also be able to operate expendably for a couple extra tons to orbit. Is this the mobile service tower looking thing and all that stuff? Is this mostly set in stone, or are you still kind of working out details as to what those assets are really going to look like?
Well, I mean, the concepts are set in stone. The details of the assets are, for example, our priority is to get to the pad in 24 and get one away.
Sure.
So we're unlikely to have the the rollover building as you see it in that state.
Sure.
And we'll do it. We did exactly with Electron, where we bring the product to market and then we'll continue to iterate on the infrastructure around it. Because if you just said I'm not going to launch until I have all of my building and all of my factory and all of everything, then you can add more years to the to the delivery
Right.
time of all of those things. But what our customers care about obviously is how quickly we can get the vehicle into operations and start flying. And the launch cadence will be relatively modest to begin with anyway. We'll follow basically the same path as we did with Electron. Sort of 3 the first year and then 6 the second year and then so on and so forth. So,
Okay.
So we're this isn't our first rodeo. We've played this game before.
Right.
It's just completely absurd to just say you're going to go out and do like 12 launches in 1 year with the first time of a vehicle. It's a very kind of learned and iterated process to to slowly build upon what you've got and build the infrastructure as you go, rather than wait until all the infrastructure is finished before you go and do anything.
Yeah.
So this was kind of the point of this image is that this was what it would look like in its fully developed form. Now, our desire will always be to return to launch site, and we think we can do that much more inexpensively than landing, downrange on a barge.
Sure.
So, from a customer's perspective, what they care about is obviously obviously the reliability and performance of the vehicle and the price. So, although we have this marine asset, it's kind of yet to be determined. How cost effective that will actually be, and once we get a little bit further down the track, then it may be more cost effective to just fly more often with lighter payloads than
Right.
actually fly
Okay.
with that extra mass and try and amortize all the cost of that marine asset.
Yeah. I got to ask real quick, since we've got this rendering up, does it launch from here? Is this the launch pad?
Correct. Yep.
I'm
That's
not,
yep.
not seeing a
Yep.
lot of like flame diverters and stuff like that. It's just on a sort of a pedestal.
Pedestal. Yep.
Yeah?
Yep. No, that's the plan. Yep.
Okay.
I mean, there is a little bit more going on there than is
Just in the render.
It's depicted in the render.
Yeah.
There is a flame, trench there, but it's not hugely deep.
Gotcha. Okay.
Gotcha.
Are there like test stands around here? Like there's a little thing. Is this just decoration, or is this like an engine test stand, or what is what do you got going on back there?
That's an existing piece of infrastructure.
Aha.
Yep.
That belongs to the old Minotaur pad, I believe.
Correct.
Right?
Correct.
Gotcha.
Yep.
Okay. There's a flare stack and some other things. And then when we were drawing on the map, the landing site is actually a little bit further down the road in reality than we see like on this render, right?
Yeah.
Yeah,
Well, I
this
mean, don't read too much into an artist and an impression.
Yeah,
Yep, yep.
sure.
We know. Yep.
You got to fit it all in the same picture, you see.
Yep.
So.
You do a little picture-in-picture downrange or something. But you know us, we see something like this, you give us a cool rendering, and then we're here like picking it apart like, oh, what's this? Is this like marine radar? What's that on that thing?
Get your scale rule out and step out how many meters it is from
Yep,
the
yep.
flare stack to the... Yeah.
Okay, the normal size of a bush at Wallops Island is about this big, so it's like... We tend to overdo it sometimes, but thank you for providing stuff like this because we love to think about it, right?
Yeah. I mean, it's just a nice way of showing all of the separate elements, right, and
Yep.
what they could be.
Absolutely. All right, Thomas,
And
how you doing?
Good. You mentioned the balance between return to launch site and downrange, and talking about how, especially because I think, especially when Neutron was first announced, you were saying this vehicle is really sized towards constellations, launching batches of satellites rather than, although of course could also do this, launching larger, heavier payloads that are a single satellite, which means that you can balance the cost of a downrange recovery versus a return to launch site recovery by simply changing the number of spacecraft on any particular flight. Is that the primary driver between the different recovery options versus expendable as well, and what you'll be able to offer eventually when Neutron's operational?
Yeah, totally. I mean, it's like I say, at the end of the day, the things the customers care about is reliability and schedule certainty and cost, and all of those things are a finely tuned engineering and financial model, for the customer. And look, if a particular customer has a payload requirement that it pencils out that landing downrange on a downrange marine asset is the most viable way to deliver their constellation, and that's what we'll do. But obviously our desire is to return to launch site wherever possible. But we need the flexibility to make sure that we can provide the best outcome.
All right.
Real quick, somebody in chat has suggested that you call your landing barge the DMA, the downrange marine asset, because then it could also be the dirty marine asset. Just could tell anybody. Chat's coming up with names for you there. So, anyways,
I like it.
Okay.
All right, so I'm going to dive into some Neutron design changes things for sure, because we've got some updates on that. But Daz, real quick, any other questions about overall Neutron stuff that we should hit first before I dive into those?
There are some more generic questions that I think I'm going to wait until the end.
Okay.
But let's talk technically about design changes to Neutron from that Investors Day update that we got.
Awesome.
Yeah.
All right, well, let's start there. And I think probably one of the biggest ones was, you've updated the fairing. You've also updated the cycle of the engine. That's kind of the Archimedes engine. So let's maybe start with the fairing. Fairing is now 2 pieces, not 4. It's less of a hungry hippo. But tell us what's up with that.
Technically, it's actually more of a hungry hippo because it's closer to a hungry hippo than it ever was.
Yeah,
a hungry hippo is just one, one thing this.
Look, I mean, this is just through the engineering refinement process. Less moving parts is always better.
Yep.
You can have a higher structural integrity of the halves than you can of the quarters. It's less number of labyrinth seals that you need to get right for the 2 halves as opposed to 4. And from an actuation point of view, it was easy as well. The plus side is you've got heavier pieces to actuate, and there's pluses and minuses. But at the end of the engineering trade, we determined it was better to do it in 2 halves than in 4 petals.
Cool.
A lot of people kind of comment about how small the pivots are and all those sorts of things. But it's important to remember that when this fairing is opened, we're at around about 100 kilometres altitude. So the dynamic pressure is super low, and we're not we're in a nice kind of coast phase. So there's no kind of huge moments. So the fairing environment is very benign.
Yeah. Plus, you're not building it in Kerbal Space Program. Like, if you were building it in Kerbal, I could picture this waggling all over the place. But in the real world, where you're in very, very thin atmosphere up at 100 kilometers, you don't have a lot of aero load pushing on it. The rocket's not actively wobbling back and forth or trying to maneuver or anything like that. So it is just almost like a delicate flower opening up without a lot of forces acting on it. That makes sense.
Yeah, one of the interesting things about the fundamental trajectory for Neutron is it's different to a kind of normal staging. Where you do the first and the second stage, and you stage at around about 60 kilometres altitude, where there's still a bit of dynamic pressure, and you've got a bit more work to do there. And like on an Electron and many other rockets, you ignite the second stage burn for a while, sort of 30 seconds in, a minute in, and then actually release the fairing because you've ascended to that 100 kilometre kind of low heat flux, low dynamic pressure environment. Whereas Neutron's trajectory, we actually hold on to the first stage a bit longer and burn it longer than you would on a traditional launch vehicle. So that when we open the fairing, we're in that similar environment. And also, when we're kind of exiting the upper stage, we don't have big tip-off issues from dynamic pressures and stuff like that want to cause some collisions. Yeah. So the actual fundamental trajectory is slightly different, and it puts more energy emphasis on the first stage. But if you actually look at the vehicle, you notice that the second stage versus the first stage is kind of almost quite dramatically small.
Yeah.
And the reason to do that is that when you've got an expendable upper stage, that's the bit that you're not recovering. So the least amount of material in there, the better, and the least amount of work that upper stage needs to do, the better as well.
Gotcha.
So if you look at the upper stage, it looks quite surprisingly small compared to the first stage. But the first stage is the bit we're getting back. It's the workhorse. So fundamentally, we're trying to make the first stage do more work than the second stage for those reasons.
It's sort of, you were talking about that as I illustrated the second stage, not drawn to scale or anything like that here. But in talking about the forces that are going to act on the two sort of clamshell fairing design, how much are you going to have to separate the second stage away from those open fairings before you light the engine? Is it like a pneumatic pusher that sort of pushes it away and then it coasts for a second to get some clearance there? You're not lighting the engine while it's inside the first stage of Neutron, right?
Nope, that would be a bad day.
Yeah.
No, so there's a few things going on there because also you've put more energy into the first stage, then you're continuing on your ballistic downrange trajectory. So if you're doing a return to launch site, for example, every second that you wait you've travelled that much further downrange, which requires that much more energy to get you back. So the manoeuvres are pretty happen in pretty quick succession. Of the stage separation, getting those fairing halves closed, and getting the first stage on its way.
Right.
And then the plan, if you can optimise it, is really where you want to be is you've got your first stage and second stage. You want to have a slight angle of attack on your first stage when you ignite your second stage. So the second stage plume can actually help with the turn. So you can use basically less energy in the turning and get that vehicle around as quickly as you can. Get those engines lit back up, and try and arrest some of that downrange, horizontal velocity.
Gotcha.
And that's got to also help you protect the top of that first stage, especially like if the fairings are still kind of closing or whatever. The sooner you get the first stage pivoting, the sooner that second stage plume isn't pointing directly into your inner stage, basically, right?
Exactly, and this isn't some sci-fi movie where it's all just and slow and whatnot. This is snap out, snap. We're not going to mess around with this.
Okay, that's a great point. Like we talked about, the first stage having the fairings that open up, the second stage comes out. Do you have to completely close the fairings before you can light the second stage? Like, do they have to be structurally attached to each other? Rocket begins to do its flip, and the second stage lights to help it flip over?
Yeah, I mean, when the fairings are in the two halves like that, obviously in the kind of radial direction, they're not very kind of stiff. So the sooner they come back together as a cone, then that's where all the structural integrity comes from. So we'll look to exit that stage, pretty quickly, and get those fairings closed, and then once that's occurred, then look, the fairing has got to have pretty decent TPS on the nose of it anyway,
right?
For the ascent heating.
Yeah.
So it's zero issue about about any plume impingement on that.
Gotcha.
But really you want to get the angle of attack between the second stage and the first stage at the right position to just help it on its way.
Help it on its way. How do you test that? Like in the terms of you've engineered the fairing halves to open up. Do you have like a weightless sort of jig in a vacuum, and you're going to have them snap open and snap closed on the ground as you're testing them, or how do you actually test that?
This is one of the few environments, few systems that actually the Earth's environment is going to be worse than the space environment.
Right.
So you can test that pretty satisfactorily down here on the ground and have a reasonable amount of confidence, because as you point out, you've got all kinds of other elements, a higher G load for one thing, and also the atmosphere and whatnot.
Okay. All right.
And does that same, talking about the fairings obviously getting their structural integrity back when they're fully closed, does that same also apply to when you can have the first stage engines firing? Like, do you need to shut down your engines before you can pop the fairing open, and then you need them closed again before you boost back?
Yep. Absolutely, yep.
Okay, so we'll expect that to be a much quicker motion then. That makes sense.
Yeah.
I think.
Yeah.
I definitely envisioned it in the slow-mo sci-fi way, but now I see why that wouldn't
That's how
really
you automatically think of just like the dead quietness of a
Blue Danube playing in the background, and it takes 5 minutes for them to open up or whatever. But it's not going to be like that. That's interesting.
Well,
Okay.
And we're travelling sort of 8 times the speed of sound. So at that point, every second that goes by, you cover a fair bit of distance.
Yep.
Right.
All
So
right.
before we move on from fairings, there was also this other thing that got announced regarding the top of the Neutron rocket when there maybe wouldn't be a fairing there. You claimed you weren't announcing anything in this slide.
Yeah.
You were announcing not a
even
capsule
labeled
or
it.
something?
I even
Labeled.
labeled not an announcement.
It
just to be
says
super clear.
right there, not a capsule. Like,
Yeah.
So I guess is what prompts. I mean, when you're just developing a new rocket, is this just something that you have to look into and say, okay, in theory, if a customer asked us to pursue this, what are the things you're keeping in mind when you develop your new launch vehicle to maybe enable some future capability, or at least the option to go that route if you wanted to?
Yeah, look, it would be totally silly to develop a vehicle of this class and not make it man-rateable. I mean, I think one thing is absolutely inevitable is there's going to be more and more human spaceflight as time goes by.
Sure.
Today, like, there's really one customer, and that's NASA. So, if you want to be purely analytical about it, I mean, there's not a great market right now.
right.
But I think my personal view is that will change. That will change in the future. So, it would be remiss of us to not be thinking about this now. And this drives a whole bunch of things. It drives structural safety factors on the vehicle. It drives how you do valves, redundancy kind of schemes and methodologies. So instead of having to go back and re-engineer a whole vehicle to make it man-rateable, then it's much better to start off with that premise from day one and say, we're not man-rating this vehicle, but we want to make sure that it is man-rateable with kind of
Right.
minimal amount of effort. So, last thing you want to do go back and do is a whole bunch of you redo all your tank structural testing because you were 0.2 out on a safety factor. So doing it now, and we get a lot of questions. How does the capsule work with the fairing? And so I thought, well, the easy way to answer this question, we'll just show a picture of what a capsule would look like, and it's pretty obvious that the capsule just replaces where the fairing is.
Yep.
Right.
That was really the point of this. And if we don't have an active program, but we're certainly thinking about it and making sure that the vehicle will be capable of it. And this is a design that would work. And that's basically it.
Gotcha. I was trying to pick it apart, and I was like, is it not a capsule announcement? Is it not a capsule announcement? But one way or the other, it's something that you're thinking about while you're going through the other design parts of Neutron so that you don't have to come back to the drawing board. Because I think you're absolutely right. We're going to have more people in space, and it's not just going to be a few governmental organizations that are looking for these rides up to their space station, their development lab, whatever it is. Hopefully we get all these things in space in the future, so to have a vehicle that can support that makes an awful lot of sense.
Yeah, and I think the thing that makes it an announcement versus not an announcement, I think it's an announcement when you give it a name.
There you
That's
go.
when it's an announcement.
Okay.
So until we give it a name, it's not an announcement. But I think it's important that people know that the vehicle will be capable of this.
It's the knack. It's not a capsule. Sorry, Peter.
yeah.
Sorry.
No, I think we need to find what is there. I'm not a particle physicist. Is there a particle that a neutron can emit or something? I don't know.
Quark or something.
That would be a photon.
I was about to say, but we already have photons.
We
That's
have
a different
photons.
thing.
Electrons can emit photons. So yeah, I mean, I think when we called it Neutron, we lost all of our rights to kind of maintain a proper atomic kind of schedule. Because it shouldn't actually be called a neutron if we're following the order of the universe.
Gotcha. And then real quick, since we like to pick these things apart, there's 4 thrusters on the button. No, I'm kidding. This is a rendering.
Here we go.
Somebody
There we
put it
go,
in the
yeah.
reflection. I noticed
Yeah,
it. Thank you, graphics designer.
Yeah.
All right. What do we have up next here?
Well, yeah. So you actually touched on redundancy and things like that, and this will tie in with the engine cycle discussion. 9 engines on the first stage with a single vacuum optimized on the upper stage. So same thing as Electron, same thing as a couple of launch vehicles around the world as well.
Yeah.
You expecting to have at least some level of engine out capability with Neutron?
Yeah, absolutely. And look, I want the least number of engines possible.
Right, sure.
And, look, having a lot of engines for redundancy is great, but then you also can make the argument you have a lot more probability of failure because you have more engines in the first place. So it all kind of evens itself out. The reality is that if you want to have one engine program, and there's a huge amount of pluses with having a one engine program, notwithstanding the fact that you actually get to build a huge amount of heritage on one engine very, very quickly. Whereas if you've got a separate first stage engine to upper stage engine, then it's very difficult to build lots and lots of heritage on that upper stage engine.
Right.
So there's lots of good and bad and all the rest of it. But the reality is that we want a one engine program, especially to get the vehicle to market quickly. Worked super well for us with Electron. And it's like you can derive this into a mathematical formula. It basically, if you want one engine, you pretty much end up with 9 on the bottom and 1 on the top. And it's simply because of you get thrust limited on your upper stage really, really quickly. You overpower your upper stage just way, way quickly. Especially when you've got a light payload that you want to get really, really far. And
sure.
We certainly hope to do more interplanetary missions with Neutron. As well as with Electron, and you just overpower your upper stage super quickly. But one thing that is nice is that when you kind of define the upper stage engine thrust, it pretty much works out perfectly for a single engine landing of the first stage. So either way, the first stage has to have a very similar thrust class engine to the second stage to meet those requirements. And your upper stage engine, generally, it's even with 9 to 1, it's overpowered. So you need a deep throttling capability.
Yep.
For your landing engine, you need a deep throttling capability.
Right, I was about to say that's got to go hand in hand.
So those two engines just sort of look the same, apart from obviously a vacuum optimized
nozzle size,
expansion cone. But
yep.
but basically everything everything above the the nozzle extension is the same requirement. That's kind of where you will end up.
I think that also helps, and we've seen this on a couple even reusable launch vehicles, where having 9 engines on the first stage also allows you to select the number of engines you need for any particular burn. Obviously, using all 9 on the way up, but when you're doing boost back burns, when you're doing landing burns, your vehicle is so much lighter that firing all 9 engines, that's going to give you all sorts of problems.
Right.
So you'll be able to select smaller clusters or engines, or even a single engine landing or something like that.
Exactly, and for those burn back, which you can of course select different engines on each particular mission, so you can keep the mission duration time constant around around all of those engines.
Yeah, like lighting 3 of 9 or 1 of 9 engines is basically thrust limiting the entire first stage, right? You just cut down the amount of thrust because you've only lit one of the engines, so all of a sudden 1/9 of the thrust. Then you throttle that even further, you get more fine control over it. Makes good sense.
Are you expecting a re-entry burn as well? So return to launch site profile, obviously you got a boost back to head back towards the landing site, but would there be another burn to reduce your re-entry velocity or anything like that, or are you expecting to be able to passively come back down?
Yeah, so we have so if it's a return to launch site, we have kind of the boost back burn. And we don't need to do a re-entry burn to manage the thermals. That's part of the the design of the vehicle, the large 8-meter diameter base and high ballistic coefficient, super low mass. Means we don't actually need to do that re-entry burn. And we've proven that with Electron, as we know how to do that. We know how to maintain good kind of control authority through that regime, and we understand the thermal environment pretty well. So it saves a lot of fuel, which is really important. And it does put slightly more onerous on your ability to get the targeting right, because sometimes during that re-entry burn you can use that to kind of clean up any dispersions for the landing. So it does put more kind of stress on your ability to get that first targeting burn right. But we have quite a lot of downrange aerodynamic authority with the first stage with the canards. Well, they're not actually canards, they're with the canards on the way up, but not on the way down.
Right, yeah.
Right.
But we actually have quite a lot of control authority there, for downrange. And if you look at the side of the vehicle, you'll see quite long strakes.
Yep.
There's a set of 2 long strakes and 2 short ones, and those long strakes are basically the glide body. So, we can, you've got a picture of it there.
Yeah,
so we can
those.
actually get Yeah. So you see that the ones on the side are longer, and then there's shorter ones. We can get quite a bit of cross range and down range with that in the canards for So you solve one problem, you create others. Of course, a rocket is just a giant engineering compromise, and there is no optimum solution. But certainly that removes a tremendous amount of energy required, and negates the need for re-entry burn.
All right.
I have a question about building that geometry, because it's got that constantly decreasing diameter. It helps you manage your thermal loads. Is that easier to do since you're doing carbon composite wrapping? Is that something enabled by your manufacturing processes, or how?
Totally. Yeah, I mean, so it's funny because in the space industry like this, the automated tape laying technology, seems new, but in the aircraft industry, it's been used, for decades for making all your, tail planes and tail fins and whatnot. Super cool. I mean, it's a giant, a giant CNC machine with an automated tape layer head on it, and it just runs in the mold literally meters a minute. And it doesn't care if it's circular or if it's tapered. It makes no difference, and it's all about the molds. And I think in the Investor Day deck there, you can probably see some pictures of some of the molds, and that's how you know the program is real. Like, the big difference between building a composite rocket and a metallic rocket is that in order to have the conviction to build a mold, basically the majority of the design has to be done. It's not like a metallic rocket where you can roll some tubes and kind of, if you want to change it, cut this bit out and add a bit in.
Right.
With a composite rocket, the kind of the downside is you have to build the molds up front. But once you have the molds, then you're in production. So that's for anybody looking to kind of measure our status of where we're at with the program. That's always a good indicator. Is like, are we building molds, and how far down that road are we?
It just so I'm clear, these, I think on this slide, these are molds, right? Right there.
Yeah, yep. And if you look at the one above that, you can get a sense of scale. So that dude standing in that plug, so that is a first stage bulkhead that he's in.
No kidding. And you take that and, like you said, it just sort of wraps that around, and it turns it in, or it creates something like this based on just going around and around those molds with the carbon fiber, the composite material, I guess, right?
Yeah, it's basically a head on the end of a robot, and the head comes down and contacts the surface of the mold and basically stripes on or paints on almost the composite, and then comes back and beautiful process. Love it.
Yeah.
It's a beautiful process.
It'd be great to see a time lapse of that, like sort of wrapping around and around and around. It seems like the thing that would be very satisfying to watch in time lapse. These, of course, are just for the Rocket Lab skate park, right? Those are just some half pipes you got going on.
Yeah.
You talked about all the high adventure activities in New Zealand, and that's another industry.
Yep.
All right.
When we talk about... sorry, go ahead, Josh.
No, go ahead.
We were going to talk about engines a bit, but you actually mentioned
Yep.
something that's tangentially related about control on the way back down, and I'm wondering what you're thinking with like reaction control thrusters. Is that going to be a system that has any sort of commonality either with Archimedes or at least with the Methalox fuel on board? Any thoughts there?
No, the RCS system is just basically cold gas.
Okay.
We've the engine cycle has it's an autogenous cycle, so we have large amounts of gas in store. And it basically, the RCS is doing a couple of things. Is obviously helping it kick around, and then helping it re-enter. During a re-entry point, the loads quickly become far outweigh and saturate the ability for the RCS to react against, and that's when you kind of switch into that regime between aerodynamic and it's in that sort of regime, and we see that with Electron. I mean, if you look at Electron's RCS system, they're about the same size as the RCS on the top of the second stage. So, when you're in space, you have all the authority you need. But once you start getting into that kind of that transitional environment, that's when things get a little bit interesting.
Yeah. Eventually, you get into a point where the air is so thick, the air is so dense, you can use aerodynamic control surfaces to sort of control your trajectory. But you have to transition. You're up in the thin atmosphere where the air's not affecting your fairing, so you can snap it open, snap it closed, right? And then you start to come back down closer to the ground. The air gets thicker, and you move into the strakes and the canards or aft canards or whatever you want to call them when they're coming on the way down, right?
Yeah, and it's kind of a bit of a nasty bit in between where your RCS is not that effective because the loads are high and there's not enough air density for the for the aerodynamic things to so you end up with large angle of attacks on some of those things, and the forces can build up pretty quickly. So there's kind of there's a clean bit at either end, and there's sort of a little bit of a messy bit in the middle.
Right, makes sense. We want to talk about the engine
let's
cycle
talk
a little
engines.
bit? All right,
You
let's
have
talk
changed
engines.
the engine cycle. It's a methalox rocket, and that goes with a lot of next generation rockets, moving to liquid methane and liquid oxygen as your propellants. But you have changed the engine cycle, and so the way those propellants are all being used are slightly different. You want to tell us a little bit about why you made that change?
Yeah, so the original plan was the GG cycle because on the face of it, it is the simplest cycle. But the challenge is that once again we kind of alluded to it before is that the upper stage engine needs quite deep throttle capability, and so does the landing engine need quite deep throttle capability. And you can do it. Don't get me wrong, you can totally do it. But what we found is that at the end of the day, like the limiting factor for a GG cycle is turbine temperature. That's kind of the surface speeds and turbine temperatures is kind of the two things you're always trading against each other.
Right.
And the whole point of this engine is just to be super reliable. Like we don't want an engine that it is all at all stressed in any way. We want to use this engine over and over and over and over again. And we just found ourselves, pushing ourselves into a corner where, to get the kind of the simple pumping with single stage and all the rest of it, we're getting into kind of turbine temperatures that we're getting pretty uncomfortable for an engine that needs to go and go and go, and then a GG cycle you kind of fall off a cliff a little bit with throttling as well. And so you end up kind of undersizing your turbine to get with the throttle hook where you want it,
right.
And then you have to that just puts you in a worse position where your turbine temperatures and speeds are getting up in the wrong way. So basically we're kind of fighting away with this, and one of the teams said, let's just do an ox-rich closed cycle, and everyone's like, we're trying to build a simple engine. This doesn't work. So it's like, no, hear me out. So actually, when we went through the analysis, what we've actually built, and the thing is, generally a closed cycle engine or an ox-rich cycle, you're doing that because you want to extract every bit of performance out of the engine. So you're doing that because you want really, really high chamber pressures, you want ridiculously high ISPs and really high thrust to mass ratios out of the engine. That's the reason why you go down that path. We went down the path for a totally different reason. Because we said, well, okay, what happens if we don't have those requirements? What happens instead of an 11,000 psi chamber pressure, we have sort of a 1,500, 2,000 psi chamber pressure? What does that do to the cycle? And actually, some interesting things happen is that when you kind of take that cycle, remove the requirements for really high chamber pressures and ISPs, you end up with a super robust cycle because the turbine temperatures are just cold, they're just cold. And the surface speeds are just super low.
Right.
So you get all the nice things about this particular cycle with really good throttleability, and you also have an avenue if you need to, if you have a moment that you can really throttle this thing up and eat into some of those margins. But you have that ability. So it's literally like a dragster engine detuned, but idling, and it's going to idle forever. It's going to idle forever, right? It's put ourselves in a really, really good position. So, look, it's a more complex cycle in some respects to develop, but we think the actual lifespan of the engine is vastly improved. We're not at temperatures or pressures that require the use of exotic oxygen specific alloys. So we're not kind of wandering into an area that gets super tricky. So yeah, I mean, I keep telling everybody we're trying to build the most boring engine possible, for an engine designer, that's probably not a crown you want to wear. But I mean, it is in doing so, we're open the sphere up to to kind of new ways of using old cycles.
Yeah, I like that because we hear, all the time people are like, oh, we've done method locks and, oh, we're pushing the boundaries, so many bars, so many PSI, chamber pressure, oh, it's all crazy, right? And in some cases you could really try to push the boundaries there, but if you're not trying to push the boundaries, you could just end up with a way more reliable engine. Like there's no reason.
Yeah, it's what are you optimizing for?
Yeah.
And we're optimizing for a workhorse. And we're not optimizing for a world record on chamber pressure or ISP. Choose your poison. There's no free lunch in this game.
Yep.
And for us, we're really good at making super lightweight composite structures. And given that the composite structure of the vehicle is the vast majority of the mass of a vehicle, if you can make that super light, then you don't need like crazy thrust levels and crazy ISPs. We've always got that that option open to us to increase performance,
right,
and increase payload capacity simply by turning a few dials. But at the end of the day, we're optimizing here for an incredibly reliable and robust launch vehicle that just launches over and over and over again, and not for any world records on ISP or chamber pressures.
Yeah, it makes sense. It seems bad to say, oh yeah, it's a boring engine. It just does its job. It runs the way it's supposed to run over and over again. It doesn't break any world records, maybe lifetime world records eventually after you launch it enough, right? But it's such an interesting balance there. You're not trying to get social media likes because your chamber pressure is so high or whatever. You just want an engine that's going to be reliable, right?
Yeah, I mean, and look, it's not a slug of an engine either, but it's certainly if you look at the cycle and our ISPs and what's capable out of that cycle and out of those propellants, we've got a heap of margin, and that's kind of like I say to everybody in the team: do you want to sit on an aircraft, look out the window at that turbine, knowing that it's literally on the limit? Of course you don't. You want to look out that window and see that thing, knowing that's going to do 10,000 hours of flight time, and at the end of it, it's still got margin. And that's exactly what we're trying to build here is shift that paradigm a bit.
Gotcha.
And that doesn't just go into the reusability aspect where, again, these engines need to be firing over and over again, not just in the number of ignitions, but also the just amount of time that it spends burning. But then also, if you get into a situation where you have this engine out capability that you're trying to eat into, or something along the lines of just a really high demanding mission, you have the option of running the engines into those margins to give you more performance, either to overcome a shortfall or to meet a demanding mission, right?
Yep, totally. Yeah.
All right.
Yep.
So we've got about 10 minutes left here, and I've been sort of sitting on some of the more generic questions, right? That I wanted to hit a couple of here real quick, Peter, if we could. This one I think is really interesting, and it's: do you think that we'll see a split between vehicle manufacturer and vehicle operator in the future? Like airlines, one company builds the planes, another company flies the planes. Is it always going to be the company building the rockets is also the company operating the rockets? How do you see that shaking out?
I couldn't see that being very probable. I mean, look, I started, Rocket Lab is like that naive kid on the panel that said, launch is going to become a commodity and we're going to shoot them off every day and all this kind of stuff. And man, what a lesson to learn. Like, if you guys know, like if you write everything down on a piece of paper that has to go right on a launch day, like a statistician would say it's improbable, right?
Right.
So, although there's as you get better and better at it and you put more and more systems in it and it becomes more and more routine, all the rest of it, but every launch is still a tremendous amount of work. So, and the coupling between like operations and launch vehicle. We have pretty much a separate operations team that launched the vehicle, but all of those, well, not all of them, but a lot of the guys were actually, involved in the development of the vehicle, so they know the systems, super well. And we still have, there's only sort of 8 or 10 people in mission control, but there's a whole team on standby, ready to jump in at a moment's notice. So, I mean, yeah, it's an interesting thought. Yeah, maybe I'm just too close to it to imagine that as a scenario, but I think it would be difficult to achieve that.
Yeah, that makes sense. There's a lot of expertise in operating the vehicles and making design changes and stuff like that. I mean, we're still very much in, I don't want to say developmental phase, but humanity as a whole going into space, we're still in a developmental phase of that, right? Not any one vehicle or anything. So not quite airline operations yet.
I think the thing that's going to really enable, in my opinion, humans to meaningfully leave Earth is propulsion. We're still burning dinosaurs, and until we get away from that, then we need like a step change in ISP.
Yeah.
Because if you look at a rocket as it is today, it's still like between 2 and 5% of the total rocket's mass is the payload you're lifting to orbit,
Yep.
and you're still sort of 90% plus fuel. So, as far as like a thermodynamic system or an optimized system, anything that says that sort of 2 to 5% of your whole system is actually the work delivered, it's pretty poor efficiency.
Right.
I mean, you imagine if your car was 2% efficient, it wouldn't be a stunning thing.
Right.
So I think the thing that's really gonna be a step change is if we can solve this kind of propulsion ISP problem, where the mass fraction of the rocket is like 20% or 40% or something like that, and ISPs in the thousands. I think that's when we really enable. Really enable stuff.
Gotcha. Well, let me tell you about our YouTube comments. Every time there's a launch, somebody in the comments is telling us about the anti-gravity technology they've developed. If only someone would listen.
Yeah.
We get a lot of those. Let's see here. What's been the biggest sort of tricky part, I guess, the hardest part of Neutron's design so far? Have you come up with any gotchas? Like we haven't seen any massive, oh my gosh, we're completely changing Neutron. Have you come across anything difficult so far?
Well, look, a launch vehicle is just a giant engineering, compromise.
Right.
I mean, there's been no kind of real slap in the faces, but I suspect they're probably to come. It's the bits that you don't know are the bits that come and get you. But I think back to when we designed Electron and how little we knew, and we were doing a whole bunch of new stuff like electric pumps and 3D printed engines, carbon composite vehicles. Like we're doing a whole bunch of stuff that was all new. Neutron, we're doing some stuff that's new as well. But the base that we're coming from and the knowledge and the learnings, I wouldn't expect it to be like huge kind of shifts because we should know better at this point.
Right.
But I would say during the very early development of Neutron, that was super fun because we started off at first principles and really at first principles. And the first picture of Neutron was a traffic cone. Kind of looked like DCX because
DCX,
that
nice.
Because that is like, and it was not a single staged orbit. Let's just be clear.
Right.
But that is kind of the optimum format. And if you look at Neutron today, it's not quite a traffic cone, but it's you squint a little bit, it kind of is because
painted orange.
Yeah, painted orange. Yeah. But I mean, your big base and let the first stage, which is the reusable part, do the majority, as much of the work getting to orbit as possible, and some of those fundamentals, are pretty key.
All right, it's almost like one of those the AI generated art where it's like, oh, draw me a perfect rocket or whatever, and it draws a traffic cone. So
yeah, I reckon that would be the case if you created a computer program to optimize it, you'd end up with a traffic cone.
All right, let's see here. Talking about Neutron and Electron sort of overlap, is Electron going to continue forward? Do you envision a time where Neutron is flying everything and you're not flying Electron anymore? How do you see that sort of working out?
No, I mean, Electron will continue as a product. I mean, there's a real market niche for it there in small dedicated launch. That's not going away anytime soon, and nor can it be replaced with a large launch vehicle. So we have absolutely no intentions to retire Electron at any point. In fact, Neutron will help Electron, and Electron will help. It has already helped Neutron. There's a lot of commonality between things like avionics and software. And one of the great things about Electron is, and one of the really tough things was that, you have no mass margin. So,
right.
The mass of a pressure transducer really matters, whereas a mass of a pressure transducer in Neutron is irrelevant.
Yep.
But what it did force us to do is come up with really, really, mass efficient and clever ways of doing things like avionics. So when we look over to Neutron and look at the kind of avionics mass budget, when we port that across from Electron, it's just crazy small.
Right.
So there's a lot of head starts that we get from that.
Yeah.
Because avionics doesn't really get that much bigger when you just put it on a new rocket. Computers are the size of computers.
Yeah, it's rocket size agnostic. It doesn't matter what size. Yeah.
Yep. How about, let's see here. You talked about having a little bit more margin in the engines because you're not turning the knob to 11. You're like happy running it at 9, and it's nice and reliable. Could you foresee any future enhancements to Neutron where it's like Neutron XL, you stretch the tanks a little bit or something like that, and you use that extra margin to carry a little bit more to payload or anything like that? Gone across the drawing board?
Yeah, totally. And in fact, the way that Neutron is architected, actually, if there was a need to increase its size, then it's a relatively academic process. Excuse me. So there's plenty of scope for that. I mean, we don't size a vehicle just kind of pick a number and away we go. Right. We've one of the advantages of flying Electron so much is we get to work with so many different customers around the world, and that's what has really driven the sizing of Neutron to date. If that evolves a little bit and either way, we can totally deal with that.
All right. Thomas, I've gone through most of the questions here that were sort of relevant to what we're talking about, beyond whether or not Peter has any seafood restaurant recommendations around Wallops.
There are a couple good ones
there's a little out there.
Yeah, there's some good ones.
Yeah, let's go over to Chincoteague. There's a lot of cool places to eat out there if they're open in the right season. So,
I've got one more question to ask, and we touched on Photon briefly, so I'm just going to touch on this as my last kind of pre-thought of question, because you got two really high-profile Photon missions coming up. We just had Capstone launched a little bit ago, and that mission's going well. It's on its way to the moon, but you got two more that are, I don't know, is the moon people keep telling me the moon counts as interplanetary. I don't know if that counts or not, but either way, beyond low Earth orbit, I guess is the right way. But you've got a private Venus mission, and you've got a mission for NASA going to Mars. Any exciting updates on either of those fronts?
Yeah, so the Mars missions, it's actually it's actually 2 spacecraft. It's a super challenging mission actually because it's not just like put stuff around Mars, as we actually have to put these 2 spacecraft and maneuver them absolutely diametrically opposed to each other, do a whole bunch of measurements and then bring them back round. So it's not just like go to Mars and hang around in orbit. There's quite a lot going on there. The Escapade program is going well, and the team's working super hard to get that ready for NASA in 2024. The Venus mission obviously is a Rocket Lab private mission. It's kind of it's almost just kind of Pete's mission a little bit, and that is a nights and weekends kind of spare time.
Really?
Use old qual hardware stuff. Yeah. Because I mean it's purely Rocket Lab and philanthropically funded. So the science team is, Sarah Sager and all of the amazing scientists that worked on the phosphine discovery. So we're teamed up with them, and the plan here is we want to send a nephelometer there and actually take some samples of the atmosphere, and it's a super high risk, super ambitious mission, but one that we really believe is important and to do. So order of mission priorities, Venus is probably at the very end, but nevertheless, any spare, not there's a bunch of that right now, but any spare time anybody has to work on that mission, then that's what happens.
All right. Well, Thomas, we have gotten all the way until 4:30 here, which tends to happen. We almost always run out of time whenever we have special guests on, but I think we've covered just about all the different topics that we wanted to talk with Peter about today. We talked about the Neutron updates, design, not only the rocket itself, but also some of the ground infrastructure and what's going on out there at Wallops. We talked about the Electron launches that are coming up there at Wallops. We talked a little bit about Photon. I think we covered everything, didn't we?
I think so. I think we're all looking forward to that December launch from Wallops, because I think NSF will be a little bit up closer with that one than the traditional New Zealand launches. So I think we're all looking forward to that.
Yep.
Peter, thank you so much for hopping on for another episode of NSF Live. It is always an absolute pleasure.
Thanks very much, guys. It's great to catch up.
All right, good deal. So, folks, thank you all for watching as well. That is going to bring us to the end of today's NSF Live. Again, massive thanks to Rocket Lab and Peter Beck for spending time on the weekend here, giving us almost 2 hours of time here talking about the cool projects and stuff that they're working on. Massive thanks to the members as well, the people who make this possible. I'm going to show the screen real quick. It looks like Michael reformatted it so the names fit, because it used to be that there were so many people supporting what we do, we couldn't fit your name all on the screen, and now we do. But thanks to the members, especially the launch directors and flight engineers who make this possible. But that is going to bring us to the end of NSF Live today. As always, be looking for us on Sundays with special guests and updates and all sorts of interesting information. It's our weekly talk show where you actually get to see our faces and what we look like. But one more time, Peter, thank you so much for spending time with us today. It is always a pleasure, like Thomas said.
Thanks, guys.
All right. Well, we are going to go ahead and shut y'all down. I'm not sure where this is going to end up. I'm sending you to one of the 24/7 streams, but I forgot which one it's going to end up on. Just wherever you end up, enjoy what you see, and we will see you nerds later. Thanks for watching, y'all.
Propulsion continues to be nominal.
Our EDT pressure looks good. Toggling up. Roger, roll, Atlantic.
Water towers fly! Yes!
Echo Delta nominal.
Flight outside SC off. Bring in SC off.
Yikes. You bet. Concur. We don't need any more of these.